Well, good day, Internet. This is part 2 of a series of when you're finding your bike's hard to start or even running crappy, focusing on the ignition system. So part 1, we went through the interlocks, which is a fancy name for the key. There's the neutral switch. Your bike's got to be in neutral. These are the most common. Clutch in, so there's a switch in the clutch, up in the handlebar, and then there's the run off kill switch, whatever you want to call it, usually on the right handlebar. I've read now that they're putting them on the brakes now, so you can have the clutch in and the front brake pressed. So you gotta check your manual, see what's there. But you also consider these are switches, so they've got to be able to be operating and allow current to go in or stop. So the next logical point I look at is the grounds and the connectors themselves, the snap connectors. Make sure they're all pushed together correctly and that your grounds are looking good. And worst case scenario, you can have a loose ground too, which will cause all kinds of weird running. Moved on to the battery. A couple quick checks of the battery with a multimeter. Okay, the next test is a test of the spark, and that involves a spark plug. Gee whiz. Just a note here, I've seen some people using the I don't know what the heck they're doing. They put a screwdriver up the end of the high tension lead and they get it close to the metal and then they turn the motor over. Okay, I don't get it. It does provide the spark, but why not use a spark plug? That's what the whole system includes. So I don't understand that. You're just risking getting zapped and doing some other damage to your bike potentially. Anyway, get a spark and just pull all the ignition wires off. It often has a crackling sound like electricity. And it has a kind of a motion like this, like pretty quick, because it's firing as the RPMs are going, or whatever it turns at, 800,000 RPM or whatever RPMs the motor's turning over. So it's trying to start, so it's doing its best. And if you don't have either one of those, like if you have a yellow spark or something like that, there's definitely some issue in the ignition circuit. And also a little trick I like to use too is like when the bike's running good, do this test. Then you'll know what your baseline is. You'll know what the crackling sound, if it makes one. You'll know what the blue spark looks like. You know what the color of blue is. And you'll have the confidence that you know what a good spark looks like. Just a note of safety, be careful around this. They don't call this high tension for nothing. This is a lot. And also doing the spark plug test, this little tool, this light gauge, they actually put the spark plug into the environment that it has to run in, which is a pressurized, under pressure inside the cylinder, which is harder for the spark to actually operate. So how these work, you can see here, is the spark plug goes in here, like this would be the normal high tension line, and then you plug this into the actual high tension line, and you'd see the spark happening in there. So this is a much more definitive test. The only problem here is that this particular design, and I've not been able to find one that actually will work with these guys, because what they've done here is, you see, this emulates the profile of the little knob that goes on here, and this one on the Yamaha and my Goldwing don't have the knob, so these don't go together, and I've not been able to find one that's made. This light tester that's been made with this knob on the top. So this might give me the excuse I need to buy a drill press and drill that out, thread it in, and put in a little bit of threaded rod or something to match up. And this end, well, assuming the spark is okay. Again, now if you have a 4-cylinder bike, you got 4 sparks to made for the knob to go in, so you might want to go through all of them. Anyway. Like if your bike's no spark on the one, then that's the knob type or whatever, with the three, of course. This is okay. So work your way back. And also use this when the bike is running right to find the coil. Then you know exactly how much it's at the end. You're not going to see a blue light in here at all. This is a coil from just a light school. You'll know what a 650. It's the round type, and these are quite different than coil per other design where you have two leads coming off one coil. You can't go off some random differely. Everything's different about it. So a word of caution there, and I'll just keep saying this. So you have to have service. They don't match. The Goldwing and the Yamaha 650, the coil measurements don't match, and they use completely different ways to measure the coil, whether the coil's okay or not. So in this case, these are called the primary leads and windings inside the coil. They are the low 12 volt circuit. Something I noticed here too, and you got to be a little careful and wise as you look at these, they've gone and put metal on the outside of here, so this is not insulated here to here. You could have an arc happening in here, so be careful there. I mean, just generally look out. And also I've noticed that this wire, very bad design, comes around and the plastic touches this metal part of this wire. So if you got some vibration and rub through on this brown wire, you could have a short there, and it would be causing this coil not to run right, especially if it was intermittent, and your bike would be running like crap, and you'd be looking at it, and you could probably measure this, and in the right circumstances it would pass, and it would fool you. So wire, just check, especially older bikes, and this one's got a tiny bit of wear in there, but it's not through. Just a bad design, very bad. So I'd clean these up and give them a shot of sealer, actually, so you wouldn't have any arcing going across here. Anyway, that's particular design that you have. So before we get to the coil, let's have a word about the high tension lead itself. Just give it a gander, make sure that it's not cracked, it's still pliable, the cap looks good, no cracks, anything like that. Sometimes you might even see arcing on here, you could smell it, it's burnt. So, okay, moving back to the coil itself. This one in particular is screw-on type, so before you got here, make sure everything's screwed together and tight. That's part of your part of the visual inspection. Anyway, you get down to the first test of the coil is the primary resistance, and it's a very small measurement in literally ohms. So the accuracy here is you got to watch a little bit. I measured this guy outside on the bike, and it's about 28 degrees out. So this thing measured 4.3 ohms outside in the cold. The range from the service manual is 3.5 to 4.3 ohms. So outside it fell into spec. Good. Just measured it inside here, and it measures at 4.6. So technically it's out of spec, but like I say, the range is so small of ohms on the meter. I wouldn't trust the meter itself and the connections that you're getting as being 100% accurate. So to me, that doesn't say the coil's bad. When you're measuring at this low ohms, you've got to make sure the scale is stabilized, the numbers are stabilized. So what you do is get in the best physical position to make contacts. Like in this case, just ramming this in here and pushing it against the table is good, and then like I said, there's a spot here I can measure against and really get a good physical contact. And I'd keep pushing and moving around so you know that you got there's a good continuity, good contact. And the best I've been able to do is 4.6 on this one. I think it's reading 4.6 right now, and stabilized. It's not ranging up and down. Alright, we'll move on to the measuring the secondary windings in the coil. And the service manual says the correct range is 6.4 to 9.6 K. So completely different range than the primary. This is single ohms, so to speak, and K means thousand, so we're into the 1,000 range, so completely different reading on range on the multimeter. And go for a range that will put the measurement that you're looking for somewhere in the middle of the range. So 20K is pretty good for that, because we're looking for 6 to 9, 6 to 10K range, so that's pretty good setting. It says to measure, the specification says it's the coil secondary, but really hard to measure just the coil. So when I measure the resistance through a primary, as it suggests, through the secondary here, which is the end of the spark plug high tension lead, it comes up with a much higher reading of 13.5K. The manual doesn't go into suggesting or recommending that you measure the resistance to this high tension, but when I do, it's this measurement only through here to here is about 5.1K. So that's telling me this is a resistance design of high tension lead. And when you take the total 13 and minus 13.5 and minus 5.1, you get the secondary windings coming up as the correct in the correct range. So that's got to be what's going on here, although the manual doesn't tell you that. So they've missed out telling you giving you a suggestion to measure this and specification. So that's got to be what's happening, because there's no way this is going to be 13.K. Okay, just a little side note on making your bike more reliable and bulletproof. In this particular design, as I mentioned, there's a little rub point there, so be aware of that and maybe do something to fix that up and seal that. But also you could do on this end of the coil where it comes in here, you know, as long as you're cleaning up that connection in there and putting this back together, I would put some dielectric grease around in here and seal that up, and then give it a good spray of silicone, you know, wire sealer, silicone spray. So all in here and, you know, right down the wire. So, you know, just make it a little more reliable when it gets wet out. Okay, so if everything checks out, or if it doesn't, you still don't have a spark, let's say, the next thing to suspect is your CDI box, your TCI, your pulsar ignition, whatever the manufacturer calls it, the infamous black box. The one thing to say there is it's pretty rare that they go out. They're pretty reliable these days. The two ways they can be broken is shock, like you drop it off your workbench or something, or you've been in the bike's been in a pretty horrendous accident, or somebody's unplugged it and plugged it back in with power on. That can zap them apparently. But overall, they're pretty reliable. But on the other side, there's not much you can test. I would personally go and make sure 100% that the ground circuit has continuity. So here we can see the circuit diagram, the black box, the ignition control unit highlighted here, and we follow the green wire coming out of the box, and it leads over to the frame ground. So check that circuit is 100% complete, has continuity. Okay, and then the other component to check are the snap connectors, shown here in green. Sure they're good and firm. All the wires are correctly in the connector. And that's about it for the black box testing, unless there's specifics that you can find in your service manual. The Honda GL 1200 Aspencade doesn't have anything. It just suggests you may be able to take it to your dealer to test. Older bikes, I would doubt that, but you know, get a newer version, model number, maybe you can get it tested out. They'll have the equipment. The other item to check is the pulse generators, or the pickups, and those are the generally mounted off the crankshaft and telling the spark when to fire. Now, they are usually just a resistance check. The only thing that could happen there is they might come loose, or they might just fail. So check your service manual for anything related to the pickups, or inducers, or pickup coils. Again, they name them a few different things, but have a look and see if they're available to test, and you know, consult your wiring diagram. That's always your best friend, and may be simple enough. Give them a quick test. Okay, that wraps her up. Just a simple test of the ignition system. A lot more complex things you can get into, especially as a result of your findings. Hopefully you got a spark and you got a working bike again, and everything's happy. So that's it for now. Take her easy. We'll talk to you soon.